Hi, welcome to this session, Open Security Summit, where we're going to talk about the sort of CDR engine standard, or file complexity and risk and evaluation, which Paul has here. The kind of idea is that CDR, which is content design and reconstruction, is still a sort of an early industry, and there's not a very good way to compare, to evaluate, to measure. Even not even between tools, but even between the same technology, open source or commercial, but even the different types of files. What basically we're trying to figure out is there's different levels of analysis. What should they be? And the objective is to come up with a sort of a common way as an industry to measure it, so that we can understand if I'm using this engine for that particular file type, I'm getting this type of protection. And then just help to have that more visibility. So over to you, Paul. Maybe just do a quick intro and then take on it.
All right, let's jump into this. So you think about the current state. Today the technologies used to figure out whether any file is malicious or dangerous are producing a simple black or white yes or no decision. So that's based on things like pattern matching for traditional AV or sandboxing, looking at behaviors. But in the end, the answer is it dangerous or is it not dangerous? And that determines whether the file is allowed in or not. What we're doing with our technology is actually taking a different approach. And one of the upsides of that is you need to then give consideration to what's in the structure of the file, what might be risk items. All that's currently ignored on the black or white decision basis. And none of the current technologies really are looking to produce a safe version so that file can be used by the organization. But what CDR is doing is actually allowing organizations to convert those malicious files to something safe and usable, and apply policy and therefore control risk in how that is done. So what we started looking at was, is there a framework by which we can evaluate the effectiveness of CDR solutions? If we looked at different file types, the type of inherent risks that come with those file types, and we can start to think about a standard way of measuring the way in which any solution from the CDR space can address those risks and mitigate them. So that's kind of where we're at today. And over time, files are becoming richer and more complex, right? It's been driven by things like storage is cheaper and much more accessible and readily available. If you need more storage, you just go and open one of the free cloud accounts. So that's causing, the file size limits to be largely ignored, and files are getting bigger and bigger over time with that richer content. Networking can also move those files very rapidly from any place to any other place. And user experience expectations are always increasing, right? So users always want smarter, more automated files that do things for themselves. And there's an increasing amount of rich content. And one example I would look at is, the new PDF 2.0 standard brought in support for something called PRC, which is a full-blown 3D modeling language that can be used. So that's a huge amount of rich content now that suddenly can appear inside of PDF documents that potentially, whilst it has huge value, can also represent more risk. And those, translate into much richer metadata sets that go around with files. They both have great upside, but they also have a lot of risk potentially for organizations when it comes to standards like GDPR. And overall, when you look at files, there's an increasing amount of attempts by the vendors of those file types, or the standards definitions, to introduce more and more security elements such as stronger encryption. Now that's both good from one point, but it is also a way of hiding and making content within those files potentially unreadable by anybody else. So there's both good and bad to that. But all of this is underpinning that ability to make files something that are richer, more usable, and more attractive to the users. So when you look at that, one of the ideas is to look at, can we classify files by the types of capabilities that they have. So on the one end, you've got something like a simple text file. You can't put images into there. There's minimal structure to the way you enter things in there. You know, simple text reading tools and text editing tools are the only thing you can use to manipulate that. And then you might have slightly smarter versions of that. But that's the end with a simple text editor. Could also be things like HTML editors, because that's pretty much flat text. And as you move to the right, you're bringing in more and more controls and format and structure inside the files, until the point where you get to the opposite end of the scale, where you've got files that can even embed other file types within it and have embedded text or images or whole files, can automate processes through scripting languages embedded in them, you know, integrated active content of all kinds. And whilst those are great from a user perspective, they can be an absolute nightmare for the IT and the security teams. So if you looked at different file types, and I would say when you look at that complex multi-part file type, and this is just current Glasswall thinking, if you think about how to classify files, and it's not cast in stone, it's a, you know, it's a thought model that we'd really like some more input and feedback on. But the kind of files that fall into that last category are things like the Microsoft Office file formats and PDFs. And then you get some other ones in the middle that might be things like a lot of the rich media files. And then at the far left is simple text files, HTML, XML files, simple flat coding text. Now, there's a secondary risk that we don't really consider right now, which is if you took something like a scripted file, what does that script actually do? Which is outside of current consideration for us. Does that make sense as a basic approach to how do we consider the risk and complexity related to any given file type?
Yeah, I really like that.
Yeah.
Because the reality is, right, you know, when you think about it, you know, the level of analysis and the level of making it safe, right, depends on that. Like, so simple files, you know, is going to be easier. In fact, what I think would be interesting here is to then map the threads, right? So you have the threads that are inherent by each of these, right? And then, for example, you have a jump. I think the jump from structured, I guess, for example, where would macros come in, right? Will they come in only on the complex or just on the structured, right?
Yeah, so I would put that under what I refer to here as active content.
Yeah, so you got, that's already unstructured, right?
Some of that might be active content that's internally focused.
Yeah.
Others might be active content that can drive external actions. Right?
Yeah. And it's kind of interesting because, for example, do you remember that WMF vulnerability a while back? Well, this goes back 20 years, right? But I remember this. There was this vulnerability where, for example, an image file format actually included code on it, right? And it was created for printers at the time, but literally it was almost some people thought it was a backdoor, but it was interesting because you actually have an image that almost have that type of active content, like had that ability to execute commands, where, you know, if you then map the image formats on this, it's also going to be interesting to see where do they fall, right? Like, do you have images that are very simple or just format, or do you have images structure that actually almost have meta language inside of it, right? And very complex things inside.
Yeah, I mean, if I'm going to just jump down a little bit, I think, to one of my supplementary files, if I can find it here. But one of the other things I started looking at is, can we map content complexity to kind of format or structure complexity? Because there are some things, and this isn't a fully formed thing. It was just a bit of interim thinking of a different way to look at the area covered by different file types. So yeah, something else to think about.
No, yeah. But I think that's a good way to start to slice this, right? Where, you know, if we start with the complexity of the files, right? You know, that will be connected to kind of what you can do with it, right?
Yeah, yeah. And the kind of capabilities that are in it. And I think you're right that, you know, if you looked at each one of those individual capabilities and we could classify them, and I think we've still got some evaluation to think about how we make that list relatively simple and generic, but each one of those potentially has a malicious enabler that it creates, right? Whether that's infiltration of data, exfiltration, remote execution, content masquerading and so on, is that gives us a framework of where is the risk and what is the risk, right? Because in the end, we have to decide which areas of these might be more important to address if push comes to shove. And that is needed if we're going to evaluate different CDR solutions to see how effective they are. So if the one solution addresses 20% of the overall issues, but they are the most important 20%, is that better than another solution that addresses the other 80% that are much less important?
Yeah, I think it would be interesting to also capture here like buffer overflows or like, things that exploit the reader, right? Although you have remote execution, but there's almost remote execution by design, right? As a feature, right?
Yeah.
And then there is buffer overflow.
Yeah, I mean, if you start
crashing things.
Yeah, if you start looking at frameworks like MITRE ATT&CK, you could make that list of risks very, very long, right? But I think we need to find a way of compressing it. And I'm not saying that the list I've got there is perfect. I think there probably are some more to add.
Yeah.
But it was just a general approach to how could we map risk areas and what is exposed by some of the capabilities in modern, rich, engaging file types.
Greg, Elvin, not to put you guys on the spot, but any comments on this?
So maybe I'll go back to this one. And
no, not for me.
Yeah.
Kind of, because I was thinking apologies if there's any noise from where I am at the moment. When I was kind of thinking about this, is just thinking about some of the NSA documents that kind of say that kind of doing the stuff on the right-hand side of the scale is actually impossible, but which I think is something we probably might disagree with. I think it's just hard.
So what's that, Greg?
Dealing with some of the NSA sort of was saying that that to do proper sort of like content CDR on some of these more complex file types is impossible, or it's possible to filter completely a lot of the more complex file types.
Absolutely right. And in fact, if I jump on a bit, how do you evaluate and assess the risks? And we've talked before about what the NSA has done with their ISG documents, right? The inspection and sanitization guidance basically says these are the most important elements to look at when it comes to the risk inherent in different file types, right? And those are supported by, they have a simple spreadsheet called the DTG that says, here's all the things you need to try and address. And back to that, if you're evaluating any CDR solution, one of the potential things to look at is, well, how many of those high profile ISG elements does any solution deal with in a given file type, right? And there's a relatively easy measure of that if you look at what the ISGs contain as clear actions for addressing each of the risks that it highlights. Right. But one of the downsides I see from looking at those is that no risk in there is given a priority. They're just, hey, these are all the things you need to think about. So it's a very flat single priority list that you get in an ISG. So a typical ISG has this kind of thing. It describes what the risk is, what the concern is, and what actions you take, right? So it's a pretty effective thing to say, well, does any solution address these kind of issues with this particular file type? Because the ISG is, as we know, unique to a particular file type, right? Does that make sense?
Yeah, and actually, I have to say, I remember when I was reading them, right? Like, I felt that was definitely something I was looking for. Even like, for example, which ones have CVEs associated with it, right? It's almost like every one of those items, there should be that kind of risk assessment behind it to say how important is this. Yeah.
And all those documents are publicly available for anybody who wants them. You just go and do a search for NSA inspection and sanitization guidance. You'll see a list of files, and they cover the main file types that the NSA really cares about, which are things like Office, PDF.
Actually, we put them on what's it called? We put them on the GitHub repo. Remember, like for the last session we did it the last time. I'll just put the link now here on the chat. But we already put them all on a GitHub repo. So oh, there you are. Somebody, Greg. There you go, Greg. You beat me to it.
Yeah, cool. Yeah, so I think it's potentially a good start point to try and build a framework to evaluate CDR tools on some kind of common basis, and it's built in and leverages the fact that an organization like the NSA has spent the time to say where the risks are from their perspective in any given file type. I would say not all of these lend themselves instantly to actions that a CDR tool might take, and some of them potentially have options built in. So it might become interesting to look at, if you look at this one where it talks about some of these, the actions to take, some of them may be mutually exclusive and you have to decide which option you're going to go down. And each one might be, certain actions might be, a more definitive response, and others might be slightly watered down. So there might be some work to do to evaluate the effectiveness of any given recommendation in here and which ones are followed. But it should at least give us a basis to potentially score the effectiveness of a CDR engine.
Can I just mention?
Yeah, go ahead.
I mean, as you probably, Paul, Greg, know, I use machine learning and to kind of evaluate the risk of a file based on CDR analysis. And it comes down to similar things, like I believe that can solve the problem. For example, we can have per file or per batch of files, an algorithm say what percentage of risk does each, I call them features, but they're basically like either issues or file content hold. So for example, if you have some active content, let's say metadata, the machine learning algorithm can actually calculate exactly how much weight it has, so how much of a risk this element was. And I believe that's quite a big step forward to actually pinpointing how much each element, because these recommendations also hold a lot of the stuff that we do, isn't it? Like we remove active content and like you have here embedded objects and stuff. So my algorithm actually does that. Like it just removes, it tells you like metadata, we decided that this file has a 80% risk, and it was decided based on metadata. It can be decided per file, but it can be also decided per batch of files. So it can be like, we found, we have a batch of files which are malicious, and the thing that was holding most of the risk was, for example, active content. So I think quite a big progress can be achieved with machine learning in this scenario.
Look, I think there's two scenarios here, right? Which is how effective is any given CDR engine at addressing the risks, versus I think what you're talking about, which is how effectively can we evaluate the inherent risk in a given file, right? Where the CDR tool is used to look inside the file to assess the risks.
But this also scores the effectiveness, because if we have like a known malicious file, and then we have a analysis which tells us like what was done to clean that file, and then we have an algorithm that digests all of that and gives us like a scoring. That means that we can have like, it's an indirect correlation between the effectiveness of CDR and the actual maliciousness of a file. So for example, also I found that the number of remediations that are done in cleaning up the file are actually directly hold a very high coefficient in the importance of maliciousness of a file. So the more remediations that we do on CDR, the more likely it is for that file to be malicious, which is kind of even like a missing link in the proof of effectiveness of CDR.
Yeah, I would also challenge on that, because I know we've seen files where one file has had, several thousand remediation actions required, but actually the file inherently was benign. And we've had another file that's had, one or two minor remediation actions, but that file was actually malicious.
But that's the beauty of science, right? Because like you've seen cases and that's anecdotal evidence.
Yeah.
But when you take it into a higher context of statistics, machine learning, and a scientific approach,
Sure.
With things like sensitivity, specificity, and calculating true positives, true negatives, it gives a bigger picture than just anecdotal evidence of we've seen it once.
Sure.
But actually, what is the overall picture? What's the forest?
But you do raise a couple of other important points, right? Which is number one, if you're evaluating CDR, most people's approach to evaluating CDR is by using current tools like AV or sandboxing, and that isn't always, in fact, most of the time, it's not a great way of evaluating whether CDR does a good job. And secondly, I think we have to be careful about not having an evaluation tool that is a black box. And whilst I absolutely agree with you that machine learning is a great way to approach this, I think if we want a tool that people can evaluate the effectiveness of CDR with, we have to be very open about the factors that we consider in scoring or assessing the effectiveness of a CDR engine.
Yeah, I mean, machine learning, despite like a lot of people thinking it's just magic, there is a lot of things that can be done for data science tries to explain a lot like how they work. So there's a lot of things that can be done, like for example something called SHAP values, which really helps a lot in explainability of the algorithms, not just having them work like magic. So there is, I think there's a huge potential there.
Yeah, I'm not don't take what I say in any way as disagreement with that. But one of the things I do like, if we use something like the NSA ISG content, is it comes from almost an independent third party that has no vested interest in writing a test approach that favors one CDR engine over another, right? It's an objective view of the risk of files inherently.
Yeah, but look, if you look, or take a view that what we're also looking at is a maturity, right, of the level of almost capability of a CDR engine, right? I actually see a world where a more evolved CDR engine uses machine learning as part, or even its analysis as part of some of the round trips it does, right? Like especially when you start looking at, because I think we should talk about here too, is the ability to create files in the end, right? Because remember that the point of a CDR is, and maybe that's something to think about as we map the levels, right? Because the objective here is to give the user a file, right? A saved file. So it's almost like a more evolved engine, for example, is the engine that can do selective reconstruction or selective sort of rebuilds, or can you again use machine learning to make a bunch of decisions on what to drop, what not to drop, right? And that will be a more evolved engine, right?
Yes, indeed. And if the ultimate objective is to generate a file that is usable by the recipient of that file, there may be more value in some of the things we're doing, like being able to create a file without any remediation actions, because that generates a usable file.
And or remediate what you can.
Yes.
Or i.e., there's parts of the document, so then the document doesn't come without page 7, or it doesn't come without this, or doesn't, comes in a maybe even visual differently. But as long as we can say that this is the reason why, and this is why we didn't let that content go through. And I actually think machine learning can play a nice role, not just on the pure malware, but also, what to let through, right? So if we could start to say macros, let's say, for example, a very interesting, situation that we're going to get into is that imagine doing machine learning also on the macros themselves, right? So you can even start to say, based on the pattern that we see on the macro, based on the bits and based on what it's doing, we think it's malicious versus we don't think it's malicious, right?
Yeah, I mean, that's what a lot of customers ultimately end up asking us about, right? Is rather than generically saying, do you or don't you allow macros, have some kind of assessment of the content of the macro itself.
Yeah, cool.
Yeah.
All right, cool.
So, yeah, there was another point that was just gone out of my head. I'm sure it'll come back to me.
Sorry, I interrupted.
That's all right. Yeah, so, some of the questions I was raising was, are the ISGs a good way to kind of objectively assess risks? And I take your point, Petra. I also am aware that, if you thought about the amount of checks and changes we potentially do through any given file type, I mean, Greg and Elvin, I'm guessing you're going to tell me it runs into tens of thousands in a typical Office or PDF file, right? And so you finding a way to represent that in a way that's easily understandable and consumable is one of our bigger challenges, which we need to find a way of simplifying that whilst still representing the effectiveness of the engine.
Yeah, but that in itself can be a metric, right? It can be a metric that, the difference between an engine that does, well, look, even we did not just between different engines, like we have different, what we call cameras, right? We have different parsers, the number of rules is already, significant between them. Now, the question is the number of rules a good measure, a good objective measure, or at least, a measure for the thoroughness, right? And effectiveness of a CDR solution, right?
Yeah. Well, I mean,
or is it more relevant to the complexity of the file itself, right?
I think it's the number of risk items that are removed more than anything else. And I'm sure there's a correlation between removal of risk items and the number of actions we take on files, right?
But I guess the other thing with doing that one is that it also depends on, if you want to do that, it should be a percentage of the known risks within that file type, right? Because, we could say, oh, look, we take, a tool takes 5 risks from Word and 2 risks from a video file, but actually Word might have 20 high risk areas and video might have 3. So actually, when you look at, in that sense, one engine is doing one camera or one parser is doing 20% of one file and 70% of the other.
Yeah. So that's the question, is how do we feel about using the ISGs to really be a basis for evaluating a CDR engine? Do we think it gives reasonable coverage, or are there other areas we'd need to consider?
I really like it, right? But actually, Greg just had a good point, right? What's missing from here is a risk assessment of these items. And actually, I think maybe a conclusion, I would propose is that one of the pieces of work to be done here is almost creating a mapping, right? Or, a graph of almost a variation of the attack trees, but almost like the types of risk that each file type has.
Yeah, right? I mean, I'd almost go a little further than that, Dennis, and we might have to accommodate a relative risk priority by individual organizations when they're evaluating, just because of the nature of the industry they're in.
Oh, absolutely. Yeah. So it's actually, I was just talking about the maturity models and the standards in the previous session on OWASP, for example, verification guide on maturity model. I think that we have to come up with a list or a way to objectively list the risks and the potential implications of each of the file types. And I think each industry or each organization will need to tweak it to say, well, I really care about these ones, I don't care about those, where you arrive at that kind of now master list of, for Word documents, I care about this. For PDFs, I care about that. For images, I care about this. And then you can say, all right, for those items, how does that particular engine or engines do on those?
Yeah, absolutely. Because one thing we have noticed is when we get into policy with customers using some of our cloud solutions, there are certain file types and issues they just don't care about.
Yep.
Yes.
And it makes sense, right? Because you could also use data to say, look, at the moment, this is not, there's no historical data to show an exploit. The kind of problems that can occur don't affect us. So, absolutely, they can say, no, I don't care. And others, they might say, I absolutely care a lot about metadata here. I absolutely care a lot about, that structure, because it's going to end up on a printer that was, or a device, or a medical device that it's 10 years old, right?
Yeah, exactly. Yeah.
And that's what I think. But I feel it's without a risk assessment, without a mapping of risks and the type of exploits, which I think you can then connect to the ISGs, because those risks have to materialize somewhere.
Yeah, but I actually see the ISGs as that existing first pass mapping of risk. There might be more work we need to do on them, but I think they're a really good first start, because they look for where the file structure and content can be exploited and is exploited in reality.
Yep. No, I completely agree.
Yeah, so more work to do to try and, I think, there's a risk, well, not a risk, but we will definitely have to get deeper into details, and that's certainly where things like machine learning will help. But we also have to keep another eye on simplifying the way which we surface this and represent, the risk or effectiveness of any given CDR solution, because we can't just present the 25,000 things we do to the file and say, yeah, we do 24,000 of those and all the other competitors do 22. That's not going to help a customer evaluate the effectiveness. So
yeah,
challenges in you like consolidating the view into something meaningful. And that was the whole point of looking at things like the simple levels of complexity in files.
Yeah, and absolutely. Let's not overcomplicate this, right? I think at this stage there's no way of compare, right? If we have a way of comparing, that's already better than where we are today.
Yeah, absolutely.
But even maybe just pragmatic speaking, right? Even from just our side, right? Like I want to compare our different engines, right? I want to make sure that when we release a new version, we can actually say we just moved the needle on X, right? We now added 5 new, we added 20, we added 100 new file types. What is the level of CDR of those file types?
Yep, absolutely. Okay, well, that's kind of as much as I was kind of wanting to get into today. I am curious with a couple of people who joined us, Chris and Andre. Do you have any thoughts about what you've heard and thinking about the topic area we've covered today?
Very insightful from my side. I found that quite beneficial, to be honest.
Yeah.
Someone who's quite new to CDR, I can see the real benefits in what it can bring to the table.
Yeah. Cool. Yeah. Andre, any thoughts from you?
I'd like to see the final results to see how do you actually will separate the qualitative measurements and quantitative measurements, because at the end, I do see that you'll be comparing tools in a like per like on the operation side of things. And from a commercial perspective, I think that you might struggle that people would adopt it, because then basically you're telling, or they will be saying that their tool is not as good as, also while exposing a lot of knowledge in terms of what the tool does in the end. So some concerns there, but it was great because I didn't know much about it anyway.
Okay. Yeah, I mean, it's quite an interesting topic area, actually getting inside the guts of files to understand where the risks lie and how you mitigate them is a pretty broad topic area. But I'd say, the NSA has probably, with their ISGs, made a really good kind of bite into that, and they're well worth looking at. If a little scary at times when you read all the ways in which some of the most commonly used file types can be exploited.
But I think in order for us to also move this kind of topic forward, I think, Paul, I think we can approach it, right? Of course, we want to invite, and again, the video is here, right? If any of the CDR vendors are listening to this, please join the party, right? I think this is something that we all need from an industry point of view to, again, raise the bar, but also to make sure that I actually think that this process will actually help to explain what it does. I actually think that one of the biggest advantages of doing this is not necessarily be the direct comparison between A and B tool, because the better ones, they're gonna probably be good at a lot of good levels. But I think that it will help to determine, which are the top players, or which are the ones that are doing a good level of CDR. But then, what are we doing to files? What in a way, what is the CDR industry actually doing? And when you look at this is a great way to explain that, right? It's a great story to say, here's a file, this file has these threads, this is how it maps, the engine does this to them. Here's another file type, has these other threads, this is what it does, right? And also future-proofs it, right? Because as new files comes along, and like you said, PDF2 comes along, introduces new things. Well, there's also a new thread model, a new thread attack tree just on that one. So I think this has the potential to be really good to explain what actually is happening under the hood.
Yeah. Yeah, and we can never forget the fact that all these things we do to the files to mitigate the risk, we have to absolutely avoid, impacting the visual layer of the file and the way the user sees it and the valuable content that's in there. So there are other factors where, another side of this is, as much as we change the file, it has to look the same to the user, and that's a critical factor when you're adopting CDR.
Actually, interesting that maybe a way to slice this is, can I just actually, Paul, can you stop sharing? Can I share you one thing? Maybe a variation of this is the session that we did at the last summit about labels, right? Were you there, Paul, on when we look at the COVID, the security labels for COVID?
No, I don't think I made that session.
Yeah, so what's interesting about this, and actually, it might actually be that this might be a better pattern, right? It's almost like, because you need almost a granularity here, right? So if you look at this, what we've done was we kind of look at, it's kind of inspired on this kind of work that the IoT security has done, and then which is basically this really cool, if you see, right, this really nice sort of almost maturity label, right, and of what is actually happening, right? Like, what does it have, what does it do, what's data sold to, or data stored where, and the privacy label, and then there's updates, etc. But you could see that this covers more of that level of granularity, right? And then, of course, this was one done for software security, right? Which could be quite cool. So what we looked at is, what are the levels that you have, right? Like, in a way, if you, for example, would compare 5 COVID apps, right? What would be the difference, right? So you can go on consent. You go from apps that ask there's no consent to also informed consent, right? What's the capabilities? What's the installation, right? Is the source code, right? Proprietary, open source. Is it, is there a plan for decommissioning data, right? But this, of course, is relative to COVID stuff. But you got things like the data retention, right? And then who owns the data, right? And then what can you actually export data, right? Can you anonymize data? Then how do you collect? So if you look at this, it's almost like coming up with a series of metrics, series of things that then you can say, do you do this for that particular camera? So one of them could be, do you preserve the file type? Do you preserve the visual identity of the file, right? Yep. Are you able to remove this? Are you able to remove that? So I think it's kind of even like what we talk about policy, but maybe zooming a little bit more on that, and then say, is the engine able to address this? And then you start with what's possible on the file, and you kind of mapped what is riskier on the file, and that gives you almost the metrics for your labels, right? Because then you can say, are you doing X? And then actually ending up with something like this might not be that bad, because it addresses the complexity of the domain we're looking at, right? But the point of all these labels, it always ends up with a top level analysis, right? A 1, 2 to 5, red, greens, etc. But I think this kind of thing, right? For example, allows, for example, one of these could be the complexity of the file, right? So one of these metrics, one of these patterns here would be, where does this file falls into the complexity layer? Is it a simple file? Because actually, the interesting thing is that the simple file will probably only have 1 or 2 of these rows, right?
Yeah.
Where the more complex one keeps adding rows, which are specific, right, to whatever that file allows to do.
Yeah, absolutely. Yeah, I think
Yeah.
that's an exercise worth doing, just to see if we can get a more detailed framework for evaluating each file type and what could and should be done to it.
Yeah, I think that's the way to do this, where we can already do that for the multiple file types. We can share it, right? And then hopefully others will join the party, right? And do the same thing, and then we have a better way to communicate, right?
Yeah, absolutely. Okay. Anybody got any other thoughts or questions they wanted to raise today?
Just one thing from me. Would this be possible to sort of reconstruct a movie file or like a photo file?
Well, in the latest engine versions, we do support a couple of video file types and many image file types. And I think we'd have to evaluate each image type or video file type separately because they may have different criteria.
Got you. Okay.
Yeah, but for example, one of the things that's really interesting, if you look at the latest version, right, we actually not just do media files, but we do, for example, executables, right? Now, you might say, well, what's the point of rebuilding executable safely where, for example, it's already binary code, right? But, to give you a real scenario, I discovered a vulnerability by fuzzing, actually, a .NET framework file where I was able to pop the framework, right? Just by opening up a file, because the vulnerability was on the, actually, ironically, I think it was on the strong, one of them was on the strong name verification. And I basically, as I was fuzzing, and I fuzzed blindly, right, actually, but as I built a tool to fuzz it, but it basically was giving me remote code execution, right, on as soon as you open the file, right? Now, this becomes a problem because at the time you could open these files, .NET files in the browser, right? And they were supposed to be sandbox, right? But with this, you could jump out of the sandbox, right? So this is a good example of if the file had gone through, an engine that would just make sure that the individual bits of the file, not the actual binary bit, right, but individual components of the file were actually correctly done, you would have prevented that exploit.
Yeah.
So that's a cool example of it. All right, man. Okay, any other comments? No, I think we can wrap up.
Lovely. Guys, thanks for your participation in the session. That was great.